So this starts our review for our end of course exam. All right, we're going to start off by solving these equations. Notice, guys, these are definitely not your typical one-step equations, are they? They're all pretty involved. And I'm really proud of how you guys did in the classwork part. All right, so here's what I need from you now. I need everybody to focus. We're not doing group work anymore. I just need you checking your own papers individually. All right, number one. Josh, what do I do first on number one? Number one, what's my step one, first step? Yes, add 17 on both sides, and I get negative 18. Okay, I bring down my negative 3x, and Anthony, how do I solve for x? Yeah, very good. Divide both sides by negative 3, and x equals 6. So I saw some negative 6 answers, so at some point in your work, you kind of dropped off a rule there, so just make sure that you follow that through all the way to the end. On number 2, we see the first of 3 problems that include distributive property. All right, so obviously distributive property is going to be an important concept on your EOC. You see it several times, and the question is asked of you. All right, is there one solution, no solution, or infinite solutions? We're going to talk more about that in just a minute also. But on number 2, can anybody tell me, after you did distributive property, what did you write now on your next step, Elizabeth?
24x minus 20.
And then minus 6 equals negative 2. That's exactly right. Okay, very good. Now, here's the next question you ask yourself. And guys, 9 times out of 10 or 10 times out of 10, when you see that distributive property, there's going to be like terms that you need to combine after that. So what like terms can I combine in the next step, Lily?
Negative 20 and negative 6.
Very good, which makes?
Negative 26.
-26. And now I'm ready to solve my 2-step equation. Mason, what would be my next step? Okay, you should be following along. Yes, add 26 to both sides. And can you just turn your chair so you can see the screen? All right, and then I get 24x equals 24. Divide both sides by 24. And this is an easy mistake to make. I've seen several people do it. They think, oh, 24 divided by 24 is 0 because they're subtracting. But remember, it's dividing, so it's 1. Okay? All right, number 3. Again, we distribute. Negative 8x minus 8. Did you guys get that? Negative 8x minus 8 plus 2x. So again, we see there's something that can be combined on the left side. What is it? Just tell me. Yes, which is negative 6x minus 8 equals negative 32. Next step, add 8 to both sides. Negative 32 plus 8 is negative 24. Dividing both sides by another negative makes a positive answer. All right, number 4. So I'm going to challenge you on these fractions. I need you multiplying these fractions without using the fraction button on your calculator. Okay, there's nothing I can do about it as far as, on your EOC, if you use the fraction button, it is what it is. But next year in Algebra 1, we're going to a 4-function calculator. That fraction button's not an option. Okay, so here's how I do it. A whole number can be always written over what? 1. So what we're saying is the whole number gets multiplied by the numerator. What is 9 times 1? 9. And then you divide it by the denominator. 9 divided by 3 is 3. It's something that once you get the hang of that, and once we kind of honestly wean you off of your dependency of the fraction button, you guys, you'll be in a lot better shape, okay? Negative 3x. Negative 1/3 times negative 12. Again, 12 times 1 is 12 divided by 3 is 4. What's a negative times a negative? Positive 4. Okay? Equals 4 minus 4x. Now I see a situation where I have variables on both sides of the equation. which one do I move? Do I want to add 4x or do I want to add 3x to the other side? You can. However, if you add 3 to -4, that gives you -1x. So now you have an extra step to get rid of the negative. Okay? So here's my advice. Add 4x to both sides. Okay? So if I moved my x to the left side, what's going to happen to my number? I move my number to the right. So I get 1x, and then I subtract 4. And what's 4 minus 4? 0. Okay? So we need to talk about a couple things. And go ahead and asterisk, or like star this problem, because this is one of the problems on your EOC. I changed a few numbers. It's going to ask you, is there one solution, no solution, or infinite solutions? If x equals 0, what is my answer? My answer is one solution. Here's why you're tempted to say no solution. Okay? And this would be helpful to write off to the side somewhere. If my x's cancel, then it is no solution. So what I'm saying is, if I had added 3x here instead of 4x, well, what's -3x plus 3x? 0x. That's where it's going to be no solution. Okay? So if your x's cancel, which is not what happened here, but if that happens on your EOC, where your x's completely cancel out, your answer is no solution. If 0 is the number value for your answer, that is one solution. Okay? All right, we did pretty well on the equations. Great questions. We're going to move on now to number 5. Number 5 is pretty easy to solve mental math. Would you guys agree? Pretty easy to solve mental math. But here's what I need to kind of reinforce with you guys is the equation aspect of it. Okay, so on the equation part of it, here's how I would challenge you to set it up, because you can only get half credit on this question. This is on your EOC as well. Okay, I'm not going to tell you all 30, but this one is, so you might want to star it. So let's say, sorry, I lost my train of thought. What operation is it going to take to solve this? Subtraction, which means the opposite operation must be connected to your variable in the equation. What's the opposite of subtraction? Addition. So that means x plus 15. Okay? Equals 82. Because now, what do you need to do to solve for x? Subtract 15 and get your answer. You say, Ms. Skinner, you just made that way more complicated. Well, what happens on your SAT when it doesn't ask you what the answer is, it asks you what the equation is that represents the situation. You have to know how to write an equation, okay? And then solve. All right, number 6, translations. Okay, so let's do a quick review on our XY axis. Which axis, X or Y, goes from left to right? Which one? The X axis, which is which value in the ordered pair? It's the first one, okay? So, does everybody agree? Listen up here, okay? Everything we do right now is a part of your participation grade, okay? So, the first number in the ordered pair is X. We just said left to right is my X axis. So, if I'm going left 4 units, what is happening to my X value? Subtract by 4. So what word would have had to be here for it to be add? Right. Go to the right. Okay? So if it's right, I add. If it's left, I subtract each X value here by 4. What's -3 minus 4? We do not need a calculator. -7. Okay? -7 and -6. How did you know -6? What word told you you were subtracting the Y value? Down. Okay, so because it said 2 units down, I subtract 2 from each y value. What word would I have needed to see there to know to add? Up. Okay. All right, what about B?
-1.
-1, 2. What about C, guys? 2, 6. All right, how are we doing on that? Are we clearing up any confusion? Okay, next section. To reflect across the x-axis, I do the opposite of my y value. So the opposite is true as well. To reflect across the y-axis, I do the opposite of x. Now, the other number stays the same. So if I'm reflecting across x, that means my x value stays the same, and my new y value is -6. All right, what about my x ordered pair, the new one? What is it? Just tell me. -3, -6. What about y? -2, 2. All right, how'd you guys do on that? Who got that right? Okay, good. All right, now the 180-degree rotation, you will not have the key on your EOC, on your end of course exam. So what is an easy way to remember what happens to the ordered pair when it's 180 degrees, Maya? Opposite of which one? The x or the y value or both? Both. Okay, so if it's a 180-degree rotation, whatever the ordered pair is, okay, and I need to scroll down, but whatever the ordered pair is, I do the opposite of both. Okay, so for point F, I just need to scroll down. Oh man, where did it go? For point F, is it here? All right, so for point F, I am going to do, what is it, guys? 2, 3. And then for point G, -2, -3. And then for point H, 4, -3. Awesome. Now let's talk dilations, okay? Scale factor that's more than 1, I'm multiplying. A scale factor that's a fraction, I'm essentially dividing, okay? You can say I'm still multiplying by the fraction, but what's happening is I'm dividing. All right, so on number 9, scale factor of 2 means I'm multiplying each ordered pair by 2. What is going to be point A? -2, -4. What about point B? Okay, and what about point C? 4, 4. Awesome. Okay, how do we do on the transformations? All of them. Okay, so that's kind of just a quick review of all of them. Now let's do number 10. How many of you are done with number 10? You're finished number 10? Okay, I want to give you just another minute or two to finish number 10. Okay, let's do number 10 and then we'll go over it. Yeah, go ahead and approximate to the nearest tenth. So there's several ways that you can set up this proportion. Someone tell me one way you set up your proportion. Josh? Equals 3 over x. But yes, that's perfect. 9 over 44 equals 3 over x. Mine was very similar to Josh. I said 3 over x equals 9 over 44. I'm still going to get the exact same answer. Did anybody do 3 over 9? Anybody do 9 over 3? Okay, as long as it matches up on the other side, we are all going to get the correct answer. All right, 9x equals 132. 9x equals 132. Divide both sides by 9. And what happens is I have to approximate my answer to the nearest tenth. Okay, 14.7. Is there a label? Is there a label? No, just 14.7. All right, that approximation is never going to go away. We'll pick up on number 11 tomorrow. We still have a little bit left in chapter 2. We'll pick up on number 11 tomorrow, and then And then do 12 and 13, which are just pretty simple answers as far as like a yes or a no and a simple explanation. But we'll talk more about that tomorrow. And then we'll get into angles, triangles, and just keep on working. All right, so that's it for part 1.